Hey everyone, welcome back to the P3 series. So today we're going to talk about the integration by substitution and integration by parts. So integration by substitution is very easy. More often than not, it can be used in like complicated scenarios, but there's a very special case where it helps to use the integration by substitution. And that is when you have a kind of a product of a certain form. So the form that we are talking about, is when you have the integral of some function. It could be powered, but its own derivative next to it. So this is the kind of product that we're talking about. This can be handled by integration by substitution very easily. So I don't want to write the general form of the integral right away. Let's first do some examples to figure out what that is, how we can do that. So let's see first example. First example, very easy one, sine x times by cos of x dx. Now if you notice, both sine x and cos x are each other's derivative. Like there's a, if you take the derivative of cosine, there's a minus sign involved, but still like acceptable thing over here. So what we can do, for example, if we take u as sine of x, we get du over dx as cos of x, which means that du is cos x dx. And if you notice, this is what du is, and this is our u. So we rewrite this integral as u du. Now this is absolutely simple. This just simply becomes u squared over 2 plus c. But when we convert it back into the sine cosine form, we will have sine squared x over 2 plus c. Now, you could have tried, in this case, it was like easy because the power was 1. Let's try out with the u is equal to cos x also. If u is equal to cos x, then du would be minus sine x dx. Absolutely fine. So the only thing missing is the minus sign over here. So what we do over here, this would be minus u du, because you don't have the minus sign. So basically what that means is minus sine x dx would be equal to minus du, plus du. Oh, sorry, the other way around. Sorry, sine x dx would be minus du. So minus sign can come out. So what this just simply does is it just becomes minus cos squared x over 2 plus c. This is absolutely fine also. Now, let's add a power on one of them. Let's say we have sine squared x cos of x dx. This is a very simple example, but still good for us. Now, we don't need the sine squared because the derivative of sine squared would be 2 sine x cos x. So we don't have the sine x. We have sine squared and cos x. So we just need the cos x. So what we do, we take the sine x instead. So we know the derivative of sine x is cos x. So that's what we need to take that as our u. So u is sine x. So similarly, du over dx again becomes cos x. So du becomes cos x. Dx, again, same scenario. This is our du. This is our u squared. So we have u squared du. So this integrates to u cubed over 3 plus c, which when you convert it back becomes sine cubed x over 3 plus c. Simple process. Now, what if you had tan? So tan squared x secant squared x dx. So we know that the derivative of tan is secant squared. So we can just simply take u as tan x. So du would just simply be, um, secant squared x dx, which is this thing. And this is our u squared. So u squared du is just simply 1 over 3 u cubed plus c. When you convert it back, this becomes 1 over 3 tan cubed x plus c. Straightforward. You could do the same operation with the reciprocal functions also. So the general form over here is starting to look like, for like the kind of the product that we're talking about, the general form of the integral looks like f of x increased to the power n plus 1 divided by n plus 1 plus c. So this is not the exhaustive case over here. Like this is not the only way where the integration by substitution is used. You could have other scenarios also. Also remember one thing, we have to change the limits also. So for example, let's have another example. Let's say you have x e raised to power x squared. Let's say you have minus x squared. And from 0 to 2, for example. So what we do is we need to identify which of these is the derivative of the other, or which can give us some form of derivative of the other. So when we differentiate e raised to power minus x squared, we get minus 2x e raised to power minus x squared. So which is okay for us. That's perfectly fine what we can do over here. So what we can do over here, this would mean that we can take u as e raised to power minus x squared, which would mean that du is going to be, same thing, minus 2x e raised to power minus x squared dx. And if we want to use x as the case over here, like just simply x, we can divide 2 on the other side. So the x e raised to power minus x squared dx is simply minus 1 over 2 du. So something like this. Notice that there's no u. We don't need u anymore because we have exactly the same thing coming back. So this just simply becomes minus 1 over 2 dq. Absolutely the way it is. Since we took u as this, we need to change the limits also. So for the limits, when x is equal to 0, so u is equal to e raised to power minus 0, so basically 1. And when x is equal to 2, u is equal to e raised to power minus 4, because 2 squared 4. That's simply just that value. So from 1 to um, e raised to power minus 4. So now when we do this, we get, so now the integration part. So integration will just simply be minus u over 2 from 0 to e raised to power minus 4. So now when we plug in the limits, so minus e raised to power minus 4 over 2 minus, sorry, 1, 1, 1, this is 1, and minus 1 over 2. This becomes 1 over 2, this becomes positive, this becomes negative, so minus 1 over 2 e raised to power 4. So that would be the exact value of this. Now, let's see some past paper questions and see what kind of problems we can use integration by substitution. In most of these cases, you will see that they will give you the expression to substitute. All right, so let's see this question. So the diagram shows the curve y is equal to sine x times by cos 2x for 0 to pi and maximum point M, where x is equal to a shaded region between the curve and the x-axis is denoted by R. Now, this is the B part of this question. The A part was finding the A. B part is find the exact area of region R, giving your answer in simplified form. So basically what they're asking is we need to find out the area of this function sine x cos 2x dx from, let's call this P and Q. Sorry, Q first. However, since this area is under the x-axis, the integral that we will get will actually be negative. So area would actually be negative of this value. But anyways, there are two things we have to do if we want to solve it using substitution. First off, we need to find out the P and Q, the limits. Second, we would need to convert cos 2x into its double angle form, using half angle basically. So first off, let's find out what P and Q are, the limits. So finding limits. So y equals to sine x cos 2x equal to 0. So this means that either sine x is equal to 0 or cos of 2x is equal to 0. So sine is 0 at 0, pi, 2 pi, and so on. Both of these are included over here. But for cos 2x, see, if we have 2x, the limit, so if x is between 0 to pi, 2x will be from 0 to 2 pi. Okay, so up to 2 pi. So 2x, this angle, cosine is 0 at pi by 2 and 3 pi by 2. Right? So that must mean that x would be pi by 4 and 3 pi by 4. So these zero crossings are now easily understandable for us. So if these are 0 and pi, these will be pi by 2, sorry, no, pi by 4 and 3 pi by 4. Okay, now we need one more thing. So these will be the p and q. So this is our p, this is our q. Now we just need one more thing. Cos 2x, we can use 2 cos squared x minus 1. Simple. So when we substitute it back, we get sine x times by cos 2x is identical to sine x times by 2 cos squared x minus 1. So that would be 2 sine x cos squared x minus sine x. So integral of sine x cos 2x dx would be like integrating this expression 2 sine x cos squared x minus sine x dx from pi by 4 to 3 pi by 4, from pi by 4 to 3 pi by 4. Now for this part, we will need to do the integration by substitution. And when we do that, we will inevitably be converting the units also. Technically, we only need that for this part so we can separate out these also, so we can do this thing also. Again, that is an optional choice, absolutely perfectly fine if you don't want to do that. But okay, this seems a little bit more easier over here. So if we consider only this, so if u is cos x, then du would be minus sine x dx, right? So this means that 2 sine x would be 2 sine x dx would be minus 2 du, simply. And for the limits, if u is equal to cos x, so when x is equal to pi by 4, cos of pi by 4 is 1 over root 2 or root 2 over 2. When x is equal to 3 pi by 4, so I think that would be minus u will be, sorry, this would be u. So u would be minus root 2 over 2. I think we can check that also. However, I think I'm sure. Cosine of minus 3 pi by 4. I may be wrong, but let's see. Minus 2. Okay. So this is our P and this is our Q. And now you can see that where the minus sign is actually going to come from. So when we apply the minus sign over here, minus sign will make this negative, which means that we can invert the limits. And this will become positive. So this would be the area. Now, since we know that the value of this function u is higher at the lower value, like 2 root 2, like more positive, and at 3 pi by 4, it's minus 2 root 2. So we can flip the limits also. So remember, in AS, we can flip the limits also. So we can go pi by 4, 3 pi by 4, 2 sine x cos squared x dx also, plus this can remain as it is, sine x dx. Now we have to use the we have to convert it into the substituted form. So we only need for the first term over here. So for pi by 4, we have root 2 over 2, and for this we have minus root 2 over 2, and the function inside becomes minus 2u squared, simply because this is minus 2 du, so this minus 2 du and u squared because u was cos, plus this remains as it is, 3 pi by 4 pi by 4 sine x dx. Now we integrate these. Now comes the integration part. This becomes minus 2 over 3 u cubed from minus 2 root 2 to 2 root 2 plus the integral of sine is minus cosine x from pi by 4 to 3 pi by 4. So when we do this, minus 2 over 3 root 2 over 2 cubed minus 2 over 3. This is going to be minus 2 root 2 this time. Plus minus cos of 3 pi by 4 minus cos of pi by 4. Now we need to find out, now we need to simplify. So root 2 over 2, cubed, this becomes root 2 times by root 2 times by root 2, and this becomes 8. So root 2 times by root 2 is just 2. So 2 root 2 over 8, which is just root 2 over 4. So this becomes, the first one becomes minus 2 over 3 root 2 over 4. These two minus becomes plus, but the cube of the negative number is also negative. So this becomes minus again. So minus 2 root 3 root 2 over 4 again. Similarly, cos 3 pi by 4, we actually found that up. That is minus root 2. So minus root 2 over 2 and plus, because minus that, and root 2 over 2. So if you notice, these two terms are identical. They're adding negatively with each other. So this is just simply 2 times by negative, 2 over 3 times by root 2 over 4 plus these two terms are also positive. So root times by 2. So as you can see, 4 cancels out with 2 and 2. 2 cancels out with 2 and 2. So we are left with minus root 2 over 3 plus root 2. So root 2 is a common. So you have 1 minus 1 over 3. So this becomes 2 root 2 over 3. And that's your final answer. All right, let's see another question. All right, so let's see this question. So the diagram shows the curve y is equal to x raised to power minus 1 over 4x squared for x greater than 0, greater than or equal to 0, and its maximum point m. Now the A part was actually finding the m point, the maximum point. However, that has nothing to do with the B part, so we are just going to focus on the B part. Using the substitution x is equal to root u or otherwise, find by integration the exact area of the shaded region bounded by the curve x-axis and the line x is equal to 3. Okay, so basically what we are simply want to do is that the area under this curve will be equal to the integral between 0 to 3 of x e raised to power minus 1 over 4 x squared dx. Now, let's see how to integrate this. So they have already given us a clue what to do over here. So if x is root u, that means u will be equal to x squared. So that means du over dx will be 2x. So du will be 2x dx simply. Now, what to notice over here is that this will be our u simply. And since we do not have 2x over here, we can multiply and divide by 2 over here. So we can multiply this 2 over here and divide by 2 over here. Or alternatively, this is one way of doing this. Another way to do this, I'll use a different color for this. Since we have x dx, so you can find out what x dx is equal to. So that is when this 2 goes on the other side, this is 1 over 2 du. So you would still have 1 over 2 du for x dx. Either way, you will have a 1 over 2 simply. So let's use the orange one. So you will have that. The green one is also fine. Okay, now let me use the green one separately and the other one separately. So 1 over 2, 0 to 3, 2x e raised to power minus 1 over 4 x squared dx. And the other way would involve the du. We still haven't actually done that yet. So when we convert this, sorry, let me write over here. So sorry, no. So when we convert this, let's put it right over here. So this will look like x dx looks like 1 over 2 du, 1 over 2 and du somewhere over here, e raised to power minus 1 over 4 u, because u is x squared, and du. What's left are the limits. So we just have to figure out the limits. So u is equal to x squared. So when x is equal to 0, u will be equal to 0. And when x is equal to 3, u will be equals to 9. So 0 to 9. Right? Okay. Now we just need to solve this. Like this was an alternate way. We don't need this anymore. So right. Okay. So we are solving this orange one now. So 1 over 2 stays as it is. The integral of this would have e raised to power minus 1 over 4 u as it is. However, we need to divide by the derivative of the power, which would be minus 1 over 4 also. And from limit 0 to 9. Now, although this 4 and this u, they look similar, so let's resolve that. So this is 1 over 2 and this is minus 1 over 4 in the denominator, so 4 goes in the numerator, so 4 divided by 2, e raised to power minus 1 over 4, 4u from 0 to 9. Now we plug in the limits. So minus 4 over 2 is just minus 2. E raised to power minus 9 over 4 minus 2 e raised to power minus 0. So 9 over 4 remains as it is. So this is minus 2 e raised to power minus 9 over 4. And this is plus 2 times by 1. So this is just the same thing, like 2 minus 2 e raised to power minus 9 over 4. So this is our final answer. Now let's see another question. Okay, so let's see this question. So the diagram shows the curve, this equation, and its maximum point m. Using the substitution, again, the first part was finding the m, the coordinate of m. Using the substitution, u is equal to 3 minus 2x, find by integration the area of the shaded region bounded by the curve and the x-axis. So first things first, we need to know the limits. We don't know the limits first, so we need to find out the limits. So when we put to find, limits, we put x plus 5 root 3 minus 2x equal to 0, or just like this thing equal to 0. So we will either get x plus 5 equal to 0 or 3 minus 2x equal to 0. So the root doesn't matter because the other side is 0. So either x is minus 5 or x is 3 over 2. Now, if we use the substitution, u is equal to 3 minus 2x, the limits in terms of u would be 3 minus 2 minus 5, and this would be u is equal to 3 minus 2, 3 over 2. So this would be 3 plus 10, 13, and this is 2 gets cancelled, so 3 minus 3, 0. Now, although like it may look like this was minus 5 and this is 3 over 2, the limits corresponding to them are opposite. So you don't have to worry about it, we just need to find the area. Alright, so we can reverse the limits also. So, right, since the area is like above the x-axis, we cannot have a negative area. Alright, now we substitute for this thing. Du over dx would just simply be minus 2, which is du or dx. In this case, for example, that would be minus 1 over 2 du. So x plus 5, so if we have root 3 minus 2x, so this will be root of u, or u raised to power 1 over 2. And x plus 5, now we have to figure out what x plus 5 is. So if if u is equal to 3 minus 2x, we need to figure out what is x over here. So 2x would be 3 minus u. X would be 3 minus u over 2. So x plus 5 would be 3 minus u over 2 plus 5, which would become 2 times by 2. This would become 10 plus 3, 13, minus u over 2, right? And instead of dx, we could have du also. So like du would be minus 2 dx over here, like whichever is satisfactory for us. So what we have over here is the area is in between minus 5 and 3 over 2 for x plus 5 root 3 minus 2x dx. So now we have substitutions for all of them. So when we convert it, that will be minus 5 was 13 and the other one is 0. So we can have 0 to 13. X plus 5 becomes 13 minus u over 2. So 1 over 2, 13 minus u. And the root 3 minus 2x is basically just 1 over 2. Dx we found out to be minus 1 over 2 du itself. So minus 1 over 2 du. So this is a longer one, so like it doesn't matter. Now let's resolve this. 1 over 2, 1 over 2 can come out, so minus 1 over 4. Okay, let's keep this as 13 and 0. 13 and 0. So minus 4, when it comes out, you can see that we will reverse the limits anyway. So we have u half, u raised to the power half. This becomes 13, 1 over 2 minus u half plus 1, the power is added. That will become 3 over 2 du. So 1 over 4, now limits reversed. You can now see that it made sense to do that before also. So this would 13 u raised to power 1 over 2 minus u 3 over 2 du. Now we integrate this 1 over 4. This integrates to 3 over 2 divided by 3 over 2 minus u 5 over 2, 5 over 2 from 0 to 30. So let's see how to simplify this before we even plug in the limit. So 1 over 4, 13 times by 2 is 26 over 3, u raised to power 3 over 2 minus 2 over 5 u raised to power 5 over 2, 0 to 30. Now we have to plug in the limits. 1 over 4 can stay outside. So 26 over 3, 13 to 3 over 2 minus 2 over 5, 13, 5 over 2 minus this entire thing would be 0. Now we just need to plug in the limits in the calculator to figure this out. Yeah, now we plug in the limit. So 1 over 4 is 0.25 times by, actually no, wait, let's do it one by one. So 13 raised to power 3 over 2 is 1.5. So since we need the exact value, oh, okay, so we need the exact value, okay. So what we can do, 13 3 by 2 is basically 13 1.5 or 1 1.5. So you can break it down like 13 times by root 13. Simple way to do this. Similarly, 5 over 2 is basically like 2, 1 over 2. So 2 plus 1 over 2. So 13 squared, 169 root 13. Simple that way. So we get 1 over 4, 26 over 3 times by 13 root 13 minus 2 over 5 times by 169 root 30. Okay, now we will need to calculate these. So 26 times by 13 divided by 3 divided by 4. So the first term will be 169 over 6 root 13. And the other term will be 2 times by 169 divided by 5. So that will be 338 over 5 root 13. So that means the answer would be root 13 times by 169 over 6 minus 338 over 5. Now we plug this into the calculator. So 169 divided by 6 minus 338 divided by 5. That is this, which is the not the right answer. So what's going on over here? Oh, sorry, I made one mistake over here. So 2 times by 169. Okay, so we have to divide by 4 also. So 169 over 10. So sorry, my bad. So 169 over 10. So 169 over 10. So 169 over 10. So 169 divided by 6 minus 169 divided by 10. That is 169 over 15. Okay, all right. So 169 over 15 root 30. So that is your final area. All right. So this video has already gone long enough, 40 minutes. So I want to keep the videos short and sweet. So hopefully we will cover integration by parts in the next video. All right. So see you all. Bye-bye. If you have any questions, don't forget to comment and reach out to me. Okay. Bye-bye.